Alright, so today we're going to work on how to write a quadratic equation. Okay. There's three different forms that quadratic equations could be written in. And each of them give you some kind of significant and important pieces of your equation, of your graph. And we'll kind of back and forth between this and the graphing quadratics. You're going to kind of see some of the connections between what these three forms do and what they tell us. Okay. So the first form we're going to look at is called vertex form. This is actually the transformational form, the horizontal shifts, vertical shifts, stretches, reflections. Okay, so this is really a nice form to use lots of stuff, and it's kind of the biggest connection to all the type of graphing we're going to be doing. Okay. What that form looks like, so it looks like y equals a. There's your vertical stretch. X minus h, there's your horizontal shift. Square, because this is a quadratic. Quadratics are all x squareds. And then plus k, that's your vertical shift. Okay, so we got the a, which stretches the graph, and if it's negative, it actually flips it, so it opens down versus the parabola, typically opening up when a is positive. Minus the h, that's your shift left or right. So if it's minus 2, right 2. If it's plus 2, left 2. And then plus k moves it up or down. Okay, so that's going to tell us some key stuff. Another good piece of information is the intercept form. Okay, or how we find our zeros. Okay, it's also our factored form. Okay, the two parentheses. So that looks like y equals a, and a is still going to be that stretch, so that's still going to vertically stretch it and flip it if it's negative. And then we have x minus p and x minus q. So p and q are your intercepts. Okay, or specifically your x-intercepts, where the graph crosses the x-axis, so p comma 0 and q comma 0. Okay. So let's come back up here. I think the key piece of information is h comma k. That's going to be your vertex. That vertex is that minimum or maximum, the lowest point or the highest point. Okay. And then lastly, standard form. This is how most quadratics are written. They're in the form y equals ax squared plus bx plus c. Okay? The only really key information you can pull out from here is we still got a, which is that stretch. Okay, so the a is the a is the a. So same a for all these problems. The one piece of information we can pull from this form is the c is your y-intercept. Okay, and it's your y-intercept because if you put 0 in for x, which we should know at this point in time, when x is 0, you get your y-intercept. So you put 0 in for x, the ax squared and the bx drop out, and you just get the y equaling c. Okay, so what we know from this form is 0c is your y-intercept. Okay? So here's what's nice. If you can put a quadratic into all of these forms, you actually know a lot about it. You know its highest or lowest point, its vertex. You know where it's going to cross the x-axis, if it does. Right? You're going to know where it crosses the y-axis. Okay, so all these forms kind of tell you some different piece of information. You put them all together, you get a really nice graph, which I'll show you in the graphing video. All right, so our goal today is how to write an equation. Okay, so you want to make sure you have these three forms down, and we'll kind of talk about when do we use each one and why, based on the information we're given. All right, so our first example is write a quadratic equation with a vertex at -2, 3 that passes through point, let's go 4, 6. Okay, so I want us to write a quadratic equation where I know the vertex is at -2, 3, and I know it passes through another point, 4, 6. Okay? So if I thought about what that sort of looks like visually before we actually write this equation, Negative 2, 3 would be left 2, up 3. And then 4, 6 would be right 4 and up 6, so something like this. This is going to be my vertex, so it's going to be my lowest point in this case, because this point's above it. So I'm going to have something, and this is going to be a pretty flat one. I'm going to have a pretty wide quadratic that's going to look like that, roughly. Okay? So we're going to kind of see how that plays out. That means our a value should be a fraction, should be pretty small and positive. That's going to really kind of squish this graph, which kind of makes it appear to be pretty fat and wide. Okay? All right, so how do I write my equation? Well, first thing I have to decide is which form should I use? Vertex form, intercept form, or standard form? Well, logic would say since I'm given the vertex, I should probably use vertex form. So I have y equals a x minus h squared plus k. One of the things that you should have seen before is that hk is the vertex. So negative 2 goes in for h, and 3 goes in for k. Very similar to writing a linear equation. We plug the points in. All right, so I get y equals a x minus negative 2 squared plus 3. Minus negative 2 turns into positive 2. That should make sense from our transformation unit. The vertex is left 2, so I need a plus 2 attached to the x. Remember, the x goes the other way. Again, this should be kind of making more sense as we go through this more. All right, so what that really leaves me to find is the a value. Okay? Well, what I also know about this parabola or this quadratic is it has to go through 4, 6. 4, 6 has to be a point on the graph. If something's a point on the graph, it must work in the equation that describes that graph. That's what the representation matching was geared to get you to understand. So what I can do is I can actually plug 4, 6 in for x and y, leaving me to solve for a. All right, so let's do that. So I'm going to put 6 in for y. 4 plus 2 squared plus 3. Now here's where I have to be very careful about order of operations. Okay? So first thing I'm going to do is I'm going to add these together. So 4 plus 2 and square it. So I get 6 equals, this is a times, well 4 plus 2 is 6. 6 squared is 36. So this is 36 times a, or 36a. And then plus 3. Okay? Very careful. Understand this is a times this, and then plus. So I can't add the 36 and the 3 together. That does not follow order of operations. Okay? So to help, notice what I did is I put the number, what this was squared, I put it in front of the a. It's going to save me from making mistakes and doing bad math. All right, now I'm going to solve for a. So I'm going to minus 3. 6 minus 3 is 3. So 3 equals 36a. So I got to divide by 36. So a is 3/36 or 1/12. I mean, that was kind of my guess that that a value is going to be pretty small, some fraction, so I could get this really wide graph. All right, so then my final equation is going to be coming back to this guy, but plugging 1/12 in for a. So my final answer is y equals 1/12 x plus 2 squared and then plus 3. And that might be off a little bit, so I'm just going to rewrite it down here. Make sure we can see it. I get y equals 1/12. That's what I found for a. X plus 2 squared and then plus 3. All right, so that's how I write a quadratic if I was given the vertex and another point. Okay, so plug the vertex in for hk, substitute the point for x, y, solve for a. All right, so second example, write a quadratic equation with x-intercepts of 4 and negative 1 that passes through the point 1, 5. Okay? So again, what does this mean graphically? Graphically, x-intercepts are points on the x-axis. So there's 4, 0, and here's negative 1, 0. So I've got those 2 points. Then I'm also telling you it goes through 1, 5. Here's 1, and then 5 might be something like that. Okay. One of the things I should learn as I go through is that the vertex has to be smack dab in the middle of the 2 x-intercepts because of symmetry. So 1's a little bit closer to negative 1 than it is to 4. So I know the vertex is going to be after this point here. So I know the graph would kind of look something, something like that. So what that's going to tell me clearly is that when I do my work here, I should end up with A being a negative number. So just kind of a little hint for me. Clearly also not as wide as the one that we did previously, so it won't be quite as small of a number. All right, so how do I do this? Well, I'm given x-intercepts, so logic would say use the intercept form. So I get y equals a, x minus p, x minus q. So what the note said is that p and q are the x-intercepts. So I'm going to put 4 in for p, negative 1 in for q. So I get x minus 4. And when I put negative 1 in for q, minus a negative turns to a plus. Okay. So again, makes sense. If I solve this to find my x-intercept, x plus 1 equals 0 when x is negative 1. X minus 4 equals 0 when x is 4. That's going to give me my 2 x-intercepts. All right. So now we're left to solve for a. Well, we just did this. We used our point to plug in for x and y and solve for a. So this time 1's going to go in for both x's and 5 for a, or 5 for y. So I get 5 equals a, plugging 1 in, 1 minus 4, plugging 1 in, 1 plus 1. So 5 equals 1 minus 4 is negative 3. 1 plus 1 is 2. So that's negative 3 times 2. So that's negative 3 times 2 is negative 6. So I get negative 6a. To solve for a, divide by negative 6. So a is negative 5, 6. All right, so I end up with the answer y equals negative 5, 6. X minus 4, x plus 1. And there's your quadratic. So let me just rewrite that over here, make sure it's on the screen. So I get y equals negative 5, 6, that was my a value. And then x minus 4, that was one of the intercepts. And then x plus 1, that was the other x-intercept. So there you go. All right, so again, very, very similar to the last one. This time I was given the x-intercept, so intercept form made sense. Plugged in the p and q. Similar, if x-intercept is positive, it's x minus. If it's negative, it's x plus. Again, anything attached to the x is the opposite. Always going to be that way. All right, last example, write a quadratic equation that passes through (1, 2, 4, 7, negative 2, 8. All right. So there's going to be some parabola out there that passes through these 3 points. 1, 2 might be something like that. 4, 7. Something like that, negative 2, 8. All right, yeah, I can kind of guess it's going to be something roughly like that that goes through those 3 spots, right? 1, 2, 4, 7, negative 2, 8. Not quite drawing a scale, but that's okay. So there's a parabola that exists that goes through those, 3 points. All right. Well, notice, even looking at the graph, I don't think those points are x-intercepts. They definitely aren't. The y values aren't 0. These points aren't the y-intercept. It's not 0 comma something. Doesn't look like they're the vertex. So vertex form, intercept form aren't going to really work. So we're going to use standard form. Y equals ax squared plus bx plus c. All right, now There's a long way to do this problem. I can plug 1, 2 in for y and x, and I'm going to get an equation that's got a, b, and c in it. And I can plug 4 and 7 in for y and x and get another equation that's got a, b, and c in it. Negative 2 and 8, plug them in, and again get, a, b, and c. And I have to try to solve this system somehow, which gets pretty complicated. But there's a short way to do it. Back in Unit 2, you learned about linear and exponential regression. Okay? Well, you can do a quadratic regression as well. Okay? So if you go to Stat, again, you can get this information back from Unit 1 and look at the video that Mr. Krenz put together for that. It's going to be the same idea. So if you go to Stat, and under List 1 and List 2, after you do Stat Edit, List 1, you're going to put your x's, just like you did for the linear and exponential. So 1, 4, and negative 2. And under List 2, put your y's, 2, 7, and 8. Okay? And then once you do that, go back to Stat and Calculate. So go to Stat, over to Calculate, and find the quadratic regression. Okay? So just kind of check in where it is, Stat, over to Calculate. Quadratic regression is number 5. Okay? So if you do Stat, Calculate, number 5, what should pop up is y equals ax squared plus bx plus c. And again, it should tell you what a is, what b is, and what c is. And then you've got your equation. Round to 2, 3 decimal places for each of your a, b, and c values. And then you got your equation. Okay? So hopefully that helps. That's actually kind of a pretty easy one. Again, refer back to Mr. Krenz's notes on how to use regression, how to set it up, which is something you should have done back in Unit 2.